So, hello everyone. Good afternoon. Hope you enjoyed your lunch. Thank you for coming to this session. And my name is Ilya from Weaveworks, based in London. And today I'd like to talk to you about time traveling in the universe of microservices and orchestration. I've been working on cloud-native tools since about 2014. And as a company, we are running commercial SaaS product on Kubernetes and EC2. And I must say, probably one of early vendors in this space. We've released ViveNet overlay network for Docker back in 2014 when I started, and it's been our flagship open source product since. However, we also built a commercial SaaS product which is called Vive Cloud, which I'll show you at the end. And time travel is essentially one of the features we have in Vive Cloud, and I'll show you a little bit of that at the end. But I'll begin by going back in time and talking about some of the experience I had in the past with Linux systems, and I'll relate to the present day when we have containers and how containers could have come so useful back then in various cases. Hopefully you'll enjoy it. It'll be not too technical talk, and hopefully quite good for after lunch talk. All right, shall we start? So yeah, as I said, I'll start by giving you a little insight into my journey in software and why do I care about these things? Why do I care to come here and talk to you about this? Hopefully, you can make up your mind by relating to it or whatnot. And then I'll show you where are we today, all wonderful things we've been able to do with containers and Vive Cloud, such as time travel. So, before I begin, I wanted to sort of to bring it up. What is it? Why do I care about containers? Why should you care about containers? I've used Linux since 2002 or 3. I can't remember for sure, and that's like 12 years, right? And I used it in work context for about 9 years now, and I've done various different things, and I'll go through some of these examples momentarily. I just want to say, throughout this time, I learned a lot through the material that community puts out there on blog posts, documentation, etc. And I really appreciate this information being given to me for free, and I'm really trying to give back to the community by going out to conferences and meetups and talking about these things. And while working with Linux, I solved various kinds of problems, but two pretty major kind of predominant themes always been packages and dependency management. That was there like from day one, except I had no idea what I was doing. I really had no idea. And then I learned a bit more, and then I learned that I learned very little, and then I learned more, and I think I'm getting fairly good understanding of it. But the tools I find most handy are, Docker containers, Docker images. That was a big breakthrough. And second thing is resource management. It's it's something that didn't hit me right away, but eventually I understood that, hey, this app is using too much memory. How do I stop it from doing that? Or I'm trying to compile something, but I'm also trying to write this document. How do I make that happen nicely and reasonably fast? So, there's magic there, but container orchestration comes pretty handy here. I wouldn't trust myself in setting up C groups or anything like that. But I'd rather tell my orchestrator to do that, whether it's Mesos or Kubernetes. However, there isn't magic. There's no magic at all. You still have to understand what are you doing. It just helps a little bit. So it was around 2005 that I went to university in England, And I got myself a desktop machine, like a normal PC. And poked around for a while. Obviously, I installed Linux right away. Right, I used Linux before that, and I installed it right there. And at some point, I kind of got bored of hardware, and I looked up what is it there that I can buy. And I got myself a Sun Ultra 5 for £30 on eBay. I like the desktop a lot. I admired the look and feel of it. I couldn't do much with it. Terminal was pretty terrible, and yeah, I mean, but it had this great look and feel. And I also really liked the keyboard. I couldn't find a photo of it, but yeah. Well, so what happened is, like, I go and install Solaris 8, which is what this box came with originally, and that worked okay. I could get the desktop. But after that, I learned about Solaris 10, which just came out around that time, and I learned about containers in Solaris 10, and like ZFS and dtrace and all these cool things. I tried to install Solaris 10, and it didn't quite cut it. I mean, this machine was too slow for Solaris 10. I couldn't really use the latest OS on that. So unfortunately, I only learned about, I got the taste for containers from documentation and videos, and like various white papers they had and stuff. But I couldn't really use containers because I couldn't run Solaris 10 on this. And I couldn't use the keyboard with my PCI. That had a different cable, but that's a separate story. So it served as a good monitor stand for a while. I didn't have room for it at some point, but anyway. So that's how I learned about containers. So, and after that, I was using Gentoo Linux for a number of years. And one of the first things you do with Gentoo, you do chroot, or actually, as you call it, chroot, right? I only learned later. I thought it's chroot. So I didn't know what that meant, but it was definitely a thing. Now that I, know about containers and mount namespaces, I understand chroot was like a basic version of that back in the day. So I really had no idea what I was doing here, but I definitely typed that. It wasn't a docs. And then I learned a bit of Bash, and like customized my prompts and stuff. Right? This isn't what I used, but this is this sort of where I learned how to customize the prompt. And that was fun. And then I compiled a lot, like everything. In Gentoo, that's what you do. You compile everything, right? You compile everything from source. So I ended up compiling like pretty much every open source project that was somewhat popular, because I was curious. And well, while compiling things a lot, I learned to control the way that my compile jobs use resources on the machine. And the basic way of doing that was this nice command, and later IO nice. And they were quite nice, but I later learned that these were really rudimentary and kind of like indirect ways of managing resources on your machine. And well, I mean, I'm not going to question whether you should be compiling your desktop OS from source or not. That is a separate discussion. However, let's move on. So I started hacking on some open source projects, and as folks been like releasing tarballs and Debian packages and Red Hat packages, etc., I wasn't getting any of those on Gentoo, so I had to compile mine. And well, why not, right? And I ended up doing this kind of thing most of the time. So it put like a new version under a prefix with the version number in it. And I would often have to specify with something path to sort of tell it like where to find some headers or whatever. And then I would install it manually. And started learning these things, started grasping how these things work. But I mean, yeah, it's like it was on very small scale of my desktop. As I progressed through my university course, I was doing electronics, and we didn't really do programming languages or computer science as such. We kind of did a bit of Python, and then we jumped straight to C, and not C on like Unix or Windows or whatever, but C on microcontrollers. That was quite fun, and but like what we did at uni is one thing, and what I did at home was like all open source and stuff, and At uni, we would use like some ancient compilers, and at home I use GCC. And I picked up some microcontroller projects from SourceForge, etc. And what you would often end up doing, because they wouldn't normally use automake or anything like that, you'd just use make, and you would specify CC, and then you go and check which one, what's the flavor of GCC that you're going to be using today. And I had multiple of those installed. A packaging management problem again, right? So yeah, would be something like that. And then sometimes you'd get like a linker error, so you got to specify LD as well. Anyway, but what I was getting to is that back then I've discovered, yeah. Anyway, back then I discovered this project on SourceForge called modules, and it was able to manage different versions of GCC on your machine. It was already quite old at the time. As I've just double-checked before this talk, it turns out that like the first release of modules was back in 1998. And it was written in Tcl, and I never actually used it. I was aware of it. I thought it'd be something I could use if I had to manage more versions of GCC for more people or whatever. But for myself, I was kind of just about managing. And I looked it up. I was quite surprised. They actually, somebody is actually working on this project, like now. They've made a lot of changes recently. And it's alive and well on GitHub, which was a fun discovery. I wonder why they're not using Docker images. They're using this old Tcl project. In any case, so as things moved on, towards the end of my university course, I got a part-time job at a hosting company, which I'll tell you more in a minute. But I was just going to say, while working on my dissertation, I learned to use Git. And you can still find that online, but that's irrelevant to the topic. That was just means of coming to the point where I got a job. So I'm working at this hosting company. They do shared hosting. This is 2007 or 8 or something like that. 9 actually. Anyway, doesn't really matter that much the way doing shared hosting. And shared hosting was still a thing. Maybe not so many people used it, but some people did. And yeah, I mean, I'm just gonna like play this little video. Essentially, like we had some of the worst dependency management, package management, config management problems. You know, there would be like, I don't know, we didn't have many servers, and there'd be different customers running their WordPress and such kind of apps on different servers, and some of them would have different versions of PHP. Like they would require them, they would depend on them, and we had to like move people around from one server to another to match up with the version of PHP they wanted. Yeah, so that kind of stuff, and you know, and don't even get me started on like resource management, because this WordPress sites got hacked all the time, and yeah, so that was a lot of fun. Anyway, well, I started Googling Linux containers. I remember Solaris containers, right? And I thought, well, containers on Linux, is that a thing yet? So I started Googling that, and I remember starting to find certain things like OpenVZ, but that was kind of complicated, and it wasn't something I was able to introduce at this company. I mean, I was like a junior support person, right? But I was like trying to figure out what would be a better solution to this. And you know, didn't even try OpenVZ at the time. Seemed complicated anyway. I was writing that dissertation anyway. So anyway, that job was over at some point. I got a DevOps job. Fancy title. Still don't know what it means. So, you know, and again, I'm managing packages and dependencies and machine resources for most of the time. So some of the things we had to deal with involved, oh yeah, so we used Puppet, for example, and at the time I was like, oh yeah, Puppet sounds cool. And I still like the syntax a lot. I think it's very nice and expressive syntax. I'm not using Puppet anymore. However, I just had this slide here because this is actually something that is quite similar to what we do today, except we do it with Kubernetes. So essentially, we were doing this kind of decentralized masterless Puppet setup, where we do a git pull, or well, pull or clone or whatever, and then we go into that directory and do Puppet apply. And we do that periodically from a cron job. So essentially, we were doing decentralized Puppet, but with this kind of thing. And it's something I'm going to show you later, how we do a similar thing with Kubernetes. Similar concept, at least. And one of the first things I've discovered was this Ruby version manager, RVM. And you do this sort of like you after you install RVM, you end up with this sort of thing in your Bash profile, right? And then after you kind of like done a couple of those things, you end up with cd command ls to this function which does magic whenever you change directories, basically, which is great. So we managed to rip that out and replaced it with this thing called rbenv, which is much simpler and nicer. However, we soon introduced Clojure and Node.js and some Python and some different versions of JVM, like Cassandra was using one, while our Clojure app was using a different JVM. Fun stuff. Containers could definitely come useful there. And this is, you probably all know this. Beside that RVM stuff, you still had to do this kind of thing where you go use one package manager to get your other package manager, and use that package manager to get your packages. No, actually, in Ruby you got the three, right? So you'd use your system package manager to install Ruby gems. Once you install Ruby gems, you install Bundler, and Bundler is like a wrapper on top of gem. I mean, things are not dissimilar in Python world. Node.js has a little less. Anyway. But it is much easier once you can encapsulate this in your container image, and you don't have to worry about it. And eventually, they'll improve their package managers, supposedly. And we also had this amazing thing called Capistrano. All you had to do is go run cup deploy production. That's all you had to do. You know what I call it now? It was a great Chaos Monkey tool, except that, you triggered it with a different intent. Anyway, let's move on. There's this other thing as well, right? There's this Git flow. Somebody was inspired by Git flow blog post, and they implemented it in Go CD, if you're familiar with Go CD. And nobody knew how to use it, really. Our software wasn't that complicated. So this is designed for folks who do version releases, and they run different versions in different environments and such things. We didn't do any of that. We didn't need any of this. So I ripped that out right away. And yeah, people just weren't aware that this is completely useless complexity that we had. Another thing I happened to implement there, I removed a bunch of things and implemented this kind of thing, which was okay. We had this pool of VMs where developer would go and say, I want a VM. They'll run VM take, and then can SSH to it and do some work and throw it away, right? And we didn't have Packer. We could have used Packer if we were aware of it, but we weren't. We used VMware. Okay, fine. But this could have easily been replaced with like a bunch of Docker containers, really, right? So, and sometime later, a colleague of mine asked me to come over to his desk, saying, well, I want to check something out. And it was the first demo of Docker on Hacker News. That was pretty amazing, pretty mind-blowing, but At the time, I kind of like, oh, Solaris containers, things I've seen with OpenVZ, this is very different. It took me a little time to get to terms with it. But I was definitely impressed with how easy it seemed to be. And then later, I started learning a bit more about Mesos, Chorus, and Console, Terraform, all these new tools. And I played around with it, and then I got a new job. I met the XRabbitMQ co-founders who just started a new company, which is called Zetio at the time. Now it's Weaveworks. And we released ViewNet just like, well, they released ViewNet before I joined. But yeah, anyway, so I started working on containers. How fun is that? So fast forward to present. What have we got? Well, let's consider ViewNet, for example. It's an application-oriented overlay network. ViewNet user doesn't really need to know anything about underlying technology, whatever it uses, VXLAN, IPsec, that kind of stuff. Users don't have to know about that. They don't have to make any changes to their underlying infrastructure to run ViewNet. And they can do things like provide identity to each of, like an IP address, get an IP address for each of their apps. Use default ports, don't have to use like port remapping for each instance of different apps, right? And we'll get to some of the examples shortly. So, oh yeah, here we go. So, like imagine this, right? In perhaps the olden days, you have two hosts, you got something running here and something else here, you got this other thing that gets this port, and then if you kind of follow this schema, you say, okay, well now I'm going to put a couple of more things of this kind here, and I go give them these port numbers, and now I got like an okay thing, I suppose. But then I introduce another thing, and I bump the port numbers again, different way, because that's supposedly somehow a slightly different thing. So if I'm doing this allocation manually, perhaps these numbers are completely different. But just imagine that you had like 3 different things, and they're using completely different port numbers, and they all have to be aware of what those port numbers actually mean. Where like, if I hit host 2 on 9081, is that what kind of app I'm going to get? Who am I going to get to talk to there, right? And you know, some people say, well, oh yeah, gets a bit more complex, as you can see. And then you're like, all right, well, let's just use DNS. But the problem is that no developer's kind of like keen to write this sort of thing. And if they want to automate that, they'd have to read a pretty big book. And they can't be bothered most of the time. But in any case, DNS comes out of the box with Kubernetes and DCOS. We don't have to care, right? It just works now. And we don't actually have to use those complex service discovery mechanisms that were built over time. You know, there are things like, I don't know, people did all sorts of things, right? I mean, my personal view is that a lot of service discovery systems like Zookeeper and Console were invented because DNS was too hard. And DNS was usually owned by an ops team and managed somehow separately and hard for developers to automate. Anyway, modern container orchestration systems comes with DNS out of the box. You can forget this. Don't have to buy that book. And if you use an overlay network such as ViewNet, you can just use default port numbers for all of your ports. Let's say all of these things talk to HTTP, right? And we use 8080 because we don't want to run it as root. And that's it. Okay, they're all on the same ports. You just connect using HTTP, host name, and 8080, and that's it. You can hardcode half of those things potentially. You don't have to do some sophisticated lookup. Unless you have a particular case where you're doing like client-side load balancing for whatever reason. And that makes sense, but for majority of the cases, you can actually just hardcode the ports and forget about port number lookups. And once we have containers and APIs, we can, orchestration APIs I'm talking about, we can implement policy. So Kubernetes has network policy, which allows us to essentially express that whatever that blue thing is, it's allowed to talk to the red thing, and the red thing is only allowed to talk to other red things, and the dark blue thing shouldn't be talking to the red thing. You know, that sort of thing. And that's something that we can do declaratively with Kubernetes Network Policy API, for example. And other things we can do with the APIs is distributed observability, and we do that with Weave Scope. So, I mean, I'm sure a lot of you are kind of familiar with these kind of situation where you'd have multiple terminals running, like htop. And you think, oh, that's cool. But like, I was never able to process all this information. I mean, I can look at one of them, and it all makes sense. But put 4 or 8 of these things, or how many we got? Yeah, I think this was 3, 4. Anyway, like too many for me to be able to actually understand. And you know, things like that too, right? Tail and multiple terminals is also pretty verbose and hard to process. I mean, if you stare at it all day, maybe you'll get used to it, but I struggle with it. I mean, it kind of reminds me of this a little bit. So yeah, up runtime metadata and APIs allow us to build richer tools with a lot more context. So, you know, imagine a situation like this. You went on the server and you found like, oh, there's a Java process, and it's using some jar that lives here. We're going to look at when that jar was last modified. Oh, that's a long time ago, right? But in order to obtain this information, you have to be aware of what's Java, jar, and what's that thing, right? Imagine you've forgotten the concept of a Java jar, right? You kind of like, you're just thinking, okay, well, there is a process. It takes some arguments. Is that a configuration file, or what is it? It's hard to tell whether this represents your actual application, right? But once you packaged it in the container, you gave it a name, and that's an application. You have a version tag. You can attach extra labels as metadata to specify some specific things like build date, something like that. You can look it up in the registry using manifest ID and find out the exact things that are in there and when they were pushed to the registry, right? So we can build richer tools having all this metadata. We can build things like what we do with Weave Cloud Explorer. We can look at all the containers whose image begins with stock shop release, and we can see where they run. We can dig into them and find out, like in graph view, we can find out who's talking to who, and we can see more information here about particular processes inside of it. There is process view as well, so you can look at lower level stuff. But essentially, you get more metadata that we can present more meaningfully to you. And this is done with zero configuration, right? And things like this, right? We can look at front-end service here and see who's talking to front-end and how much memory the neighbors are using, for example. And we can also go back in time. This is a time travel feature. I'll show you a live demo afterwards. You can go back in time and find out what happened last night. So they look at it, 79 meg now, 71 meg last night. Well, not that different. And if you actually want to find out more, you can click here and you'd go to the monitor view where you can explore metrics and Prometheus. We'll get to that shortly. And you can also log into any of these containers and take a look whether, well, this is just the standard output of the container. You can also drop into the shell inside the container as well if you want to check whether there's something that you want to do some manual check of some kind, or just take a look whether the output looks right still. This is something you can disable in production also. This is more of a development mode. And other things we are able to do with APIs. We're able to do what we call GitOps, which is what I showed you earlier with Puppet, right? We do a similar thing where, well, you'd think it's just a git pull, kubectl apply in a loop, but it isn't really. It takes a little more than that, because you want to be able to log things, you want to be able to update image attribute whenever there are new images, and do other things. So here's the Weave Cloud Deploy UI. It shows you, we're looking at front-end service here. This is the image tag we're running right now. That's cool, but we can take a look at the latest change that's been applied to the cluster. And we can see that, okay, well, it got automated. So essentially, well, in this case, I clicked on that button earlier and I automated the service. So if it sees a new tag in the registry, that will get updated in Git and synchronized with the cluster. And when I click that button, we stored an annotation in YAML that essentially means if you were to take this Git repository into a different cluster, this will be picked up from there, right? So if you rebuild a cluster or something like that, or you just want to clone an environment. So you can also, you can also use Git in all different ways that you can use Git. For example, Git blame, right? You can see what changes, who made them and when. So this particular one, I made most of the changes, but the automation tool, Weave Cloud Deploy, set this particular annotation here. And you can correlate those with metrics we have in Prometheus. Here's a deploy event that caused a spike. What was that? So this is memory usage, I think. It's kind of pretty low. However, no, that's inodes, but who cares? I mean, there's the same spike in iRate for like instantaneous rate of CPU usage. Over 5 minutes. There's a spike there too, and there's a spike here. So I looked at this particular one. I found this Git revision, right? I went in Git and looked it up, and it turned out I scaled the load test deployment to 24 pods. Now that's what caused the spike. It went away right away, but there was a spike nevertheless. So now I'm going to show you that this is all real. It's a very simple demo showing how this works with Kubernetes on DCOS today. Cool. Yeah, well, let's hope it all works still. Yeah. Okay, so I have my CloudFormation console here. Can everybody see this? Great. I have my CloudFormation console. I have DCOS. I hit this DNS domain. Okay, so I'm in DCOS. I can see I have Kubernetes installed. I'm running the latest version of Kubernetes. It looks fairly happy, and I can take a look at. I've forwarded the port earlier, so and here I got my Kubernetes nodes, and I got some pods in the system namespace. Amongst those, I can see some pods with Weave prefix. So those are all the Weave Cloud agents. And hence, it looks like the status is all good. So I should be able to use Weave Cloud now. Okay. So just to be clear, like I mean, Weave Cloud is 2 months free trial. It's a SaaS product. You run agents in your cluster. We present you this UI and all the features that come with it. So here's my Kubernetes cluster running on DCOS, and I can take a look at any particular things here, right? So let's take a look at, for example, Weave Cortex agent. What is this? So I can see there is a pod. Let's take a look. I can already see that it's running Prometheus, right? So this is Prometheus, and Prometheus scrapes from all services it sees in the cluster, and that's why it's talking to everybody. Okay, I'm happy with that. I can see there is a load test against the front end, and the load test runs some Python process. It's got 24 pods. Let me take a look at some of these pods. So for example, I can do this. I can go to this pod, and I can look at this pod in pods view. If I drop out, I see that there are all these pods here. I select front end. I can see all the pods that talk to it. Let's pick one of the. Well, I'm gonna narrow it down to load test and sockshop namespace, and I'm gonna look at one of the load tests. Just double check it's not getting any errors in the terminal. Okay, standard output them in. So I can see that. Cool, looks good. Okay. So if I'm super curious, I can actually go into one of the containers inside this pod and have a look at what it's doing. Ooh, is this working? Huh? It worked earlier. The only problem we may have is Wi-Fi. Oh, cool. All right. Okay. So what do we got? Well, I'm just going to do this, right? Okay. It's running this, and there is this config file that specifies the load test. So if I'm like, supposedly I'm very curious, what's in that config file? Okay. Fat fingers today. Config. Oh yeah, it's .py. I missed that bit. So yeah, and we can take a look at the code that's running in this container if we really wanted to. Anyway, what else I can show you? Oh yeah, I can show you monitor view. So there's the Prometheus metrics, and I have a few things here. We got node resources. We can see all the stats about memory and CPU usage from all the nodes in Kubernetes cluster that is on DCOS. This doesn't currently run on all the DCOS slaves, but that can be done too. So we can take a look at the last couple of days, for example, a whole week even. I can see, actually it looks like, so we can see like deploy event here, right? What I showed in the screenshot earlier, we can see that there's a particular git commit deployed at that time, and there were some other things deployed earlier. And we can see that, well, this is probably the time when I created the cluster. And here at the time, I think, when I've deployed the sock shop, yeah, we can see like, you know, the definitely spikes and all the graphs around about this time. So yeah, that looks like when I've deployed the sock shop app. So, okay, well, let's take a look at the deploy history. When we kind of like in the overview, we can see all the different events that took place. We can have a look at some of these things that I showed earlier. For example, this thing I think we had on screenshot, yeah. Okay, so we go to GitHub, we can see this. And we can navigate this repo, we can view the file and potentially look at history and see all the commits that there are. So, and you can see that there are the automated commits from the system, the Flux user, and there are commits from me. So I can make changes to the repo, as well as the Weave Cloud deploy makes changes to the repo. So going back to Weave Cloud, you can take a look at this front-end service, for example, and you can see all the events that relate to the front-end service more specifically, right? And now I'll show you the time travel feature. If I go back to live mode, or actually I can go straight back to time travel. So there are 3 main modes: live, pause, and time travel. So if I go back to the time before I deployed the sock shop, I can zoom out, and I think that was on the 24th. Right, we can see that there are a lot less things here. We can see there are just the system pods, or we can even look just control is probably easier to look at. And sometime around this time, I deployed the sock shop, and later, so this time the load test is already has 24 pods. So if we keep this selected, we can go back a bit, and I think at the beginning I only had 2. I need to fine-tune my time scale here. Okay, yeah, it was around that time of the night. Clearly this is not the production system, this is just a demo environment, so I've been working at it late at night. Yeah, we can see how this was different a little earlier on. Oh, this time scale is like super fine. I gotta zoom out a bit more. Yeah, so we can see now it's 2 pods, right? And you know, we can observe things like this. So yeah, well, here comes time travel. I think I actually managed to finish this earlier than I thought. We didn't overrun. We still have time for questions. Please.
Does it understand layer 7?
No, we don't have insight into what goes on at layer 7. Like, as in, you mean HTTP requests? Yeah. No, we haven't got insight into that.
So it operates on layer 3?
Yeah, but we do have a plugin that looks at layer 7. There's a plugin that is able to introspect HTTP requests using eBPF.
Cool. And does it use kind of TLS like VXLAN or?
For networking?
Yeah, between the nodes.
Well, in this demo, I actually did not use ViewNet, and ViewNet is not required to use Weave Cloud. ViewNet is a separate project, essentially, and the visualization that you saw, that does not depend on the network. You can use that with any network.
Oh, cool.
Yeah, but if you'd like to use ViewNet, we use VXLAN and IPsec as well.
Cool.
Some of our customers who use DCOS chose ViewNet because they need encryption actually, and we provide IPsec that is really easy to configure. Actually, you don't have to know anything about IPsec to use IPsec and ViewNet.
Cool. Thank you.
Thanks.
Any other questions? We're recording.
Is there any kind of performance hit on running the agents?
No, it's pretty low overhead. Yeah, we worked pretty hard to make, for example, the Explore UI. That did have a performance impact, and we managed to optimize that by switching to eBPF, which is this kernel technology that allows you to do interesting things in kernel space. So it's pretty fast. And yeah, some of the other things like Prometheus are pretty low overhead. Are we good?
Thank you.
Okay. Thanks a lot, everyone. Thank you.